Hey there and welcome to the caloric calculations as well as the macronutrient components of the fitness chapter. I'm super excited to get started. So let's get going. In this example, we're going to understand exactly how macronutrients, caloric calculations, and all the measurements work. And then in the next section, we're going to be going and deep diving how to actually calculate those requirements for ourselves. So a lot of this information is withheld from most of society, or we don't really teach one another how to do this when this is I would say, a quintessential part of being healthy. And this is why we're giving out this information for free, because this type of information should be free. So without further ado, let's get started. Caloric calculation. So calories, pretty much, I'll just make this smaller. There we go. Calories are pretty much our engines. So it's the energy component of our lives. And obviously you can read this, pause if you want to, but I'm just going to skip through it a little bit quickly. Then we have TDEE is the total amount of energy that we exert in a day. So that's a combination of our BMR, our activity multiplier, and our thermic effective food. So our BMR is essentially how much energy we're going through while we're sedentary or while we're at rest. So pretty much the essential bodily functions, breathing, blood circulation, protein synthesis, etc. Activity multiplier is how much energy we're exerting depending on our level of activity. And then thermic effective food is like the cost of digestion, pretty much. So that's what TDEE is, if you ever see that around. BMR calculations, already explained that. Like when we're sedentary, we're asleep, how much energy we're burning. Life-sustaining functions, we went over that. Thermic effective food, we already also went over that. Is the amount of calories the body uses to digest food, pretty much. So if you hear those, now you know what they are. Cool. Activity multiplier, same thing. We just multiply it depending on the range of the exercise we're currently conducting. The higher of exercise, the higher you're going to multiply how much food you need to eat. And then this is super important. So housekeeping with all caloric calculations. So this is something that almost nobody talks about, is all expenditure tracking is usually done with heart rate measurements. Now, the thing is, heart rate measurements for caloric exertion calculations are not very accurate. This is because if I swing my arm like this, my heart rate isn't necessarily a perfect representation of how many calories I just burned by doing that, if that kind of makes sense. So every calculation that you're going to see on when we teach you how to calculate your own requirements, or if you go online and you type in activity calculator, whatever, TDE calculator, those measurements should be taken with a grain of salt because they are not that accurate. Super important before we keep going. So then really cool, now we're going to talk about the three main macronutrients. So I'm sure you've heard of these before. We have fats, carbohydrates, and proteins. And pretty much they work in fuel tanks. It's a very easy way to visualize it. Every different component has its own specific fuel, if you would, and they're each responsible for their own. So just like this is our total energy, and it comes from foods, meat, plant-based protein, apples, bread is carbs, fats, almonds, avocados, super simple stuff. Just like an engine, right? Same thing. Big engine here, and then the macronutrients are the fuel tanks. And this is how it's distributed. So we have our vital functions, smell, eyesight, activity is distributed through energy output. Same thing with an engine, right? It fuels the AC, electricity, drivetrain, components, etc. So carbs. Carbs are our body source of main energy. They're easily visualized in immediately absorbing foods. So sugar, lettuce, tomato, bananas, bread, etc. These foods digest super quickly, and usually unused carbs convert into fat if there's a caloric surplus present. Carbohydrates are our main source of fuel. That's the way in which the fuel tanks are organized. It's the biggest tank out of the three. Protein. So the thing with protein, and we're going to dive a lot deeper into this in this section here, is it is important to note that there are different qualities of protein and that not all sources of protein are the same. Although protein is essential, it is dense in some instances and it is not as dense in other instances. For example, a steak is going to have a lot more protein per 100 grams than beans, right? So yeah, that's just something to keep in mind as we keep moving forward. Genetic guidance with protein. So this is pretty cool. Now, if you're a meat eater, if if you're a carnivore, if you're a vegan, it doesn't really matter. Like, it does matter, obviously, the way you eat and stuff. But what I'm trying to emphasize is that here at Optimability, we're trying to dig deep and find the science behind the best and cleanest ways to eat. So through my research, through eating 2 pounds a day of meat, through cardiovascular training, through biking up mountains, through running half strength training every day, what I have found that works best for maintaining high performance and high cardiovascular health is usually a plant-based diet. So plant-based diets do consist of, you can still eat animal products, but your main source of protein are coming from plants. So all originating sources of protein come from plants. Animals are pretty much just the middleman. That's the way the science is. It's the way things are organized. And we can ascertain all nutrients, vitamins, and minerals that we require from plant-based sources of protein rather than animal-based sources of protein. And actually, this is pretty cool. So the strongest, biggest, and largest animals on this earth are elephants, rhinos, horses, gorillas. All these big animals, they don't eat meat, right? So how do their muscles grow? Get it from plant-based sources of protein. And we're going to dive that deeper. So usually with plant or animal-based sources of protein, the problem is it's what's tied into the density associated with the animal-based protein. So 576.48 milligrams of added cholesterol, 62.29 grams of saturated fat, and 71.09 grams of monounsaturated fat. Monounsaturated fat is good, but it depends how many quantities you're getting. So that's just in 200 grams of a cow, for example, which is, we don't need added cholesterol, saturated fats, or trans fats for any sort of bodily function. We're going to dive into deeper detail about that later, but just so you know. And it's the same across the board with all sources of animal-based protein. They contain things that our body does not need to function, whereas plant-based sources of protein contain no traces or very little traces of damaging components like saturated fat, added cholesterol, and trans fats, which have been prone to cause cardiovascular disease, which is the #1 leading cause of death in the States. So something cool. You won't learn that in school. Plant-based protein contains 0 traces of damaging arterial plaque components. So pretty much what happens is these components block our arteries and over time cause a ton of cardiovascular health problems and just health problems in general. And this is why we're seeing a lot of older patients transfer towards veganism, where they're not really getting those damaging components anymore and they're going back to their normal ways and living a healthier life. So on average, around 64 times more antioxidants when consuming plant-based sources of protein in comparison to animal-based sources of protein, in effect reducing inflammation, increasing gut health, all that good stuff. You can still eat animal-based sources of protein and get terrific results. However, it's good to emphasize and to see that consuming too much animal-based protein can actually be holding you back from your cardiovascular endeavors, as well as some of your strength training endeavors. Again, it depends severely on the goals, but it's good to know these things. Now, here's a cool comparison. So filet mignon in comparison to black bean. So if you look at the saturated fat and the trans fats, we're at 0, whereas here the saturated fat's at 13 and the cholesterol's at 145 milligrams. So same thing, none in black beans. This is actually a really good point. So the problems do not arise from the consumption of meat and animal products. They arise from a lack of knowledge on how to weigh out proper protein consumption. So we've been told our whole life that we need to eat meat as our main source of protein. And if you're seeing across the board on social media, YouTube videos, that just simply isn't the case. We don't need to have meat as our main source of protein. So high intakes of sodium in processed meat products and low intakes of fruit and vegetables were associated with a 45.5 risk of cardiometabolic deaths in the United States. And this is the article. So half of all cardiovascular deaths, which is the #1 leading cause of death in the US, is caused by increased intakes of sodium and processed meat ingredients, sodium which holds in fat. So super interesting stuff. Digesting protein, there's a lot of science behind this stuff, but pretty much there's certain inflammatory molecules like trimethylene and oxide, which are created when we consume animal-based protein and animal products in general, which usually we don't need and we don't get. That's something super interesting, but very big rabbit hole to dive down. So pretty much the gist of it is, if we're consuming plant-based sources of protein, we're going to experience little to no inflammation or bloating. This is because our stomachs are not being inflamed when we're trying to break down the components of the food. Now, this is where we're going to dive deeper into protein requirements. So this is super concept that we hear about all the time. So I need to eat 400 grams of protein a day. I need to eat 300 grams of protein a day. I'm like to gain muscle mass. That's just not true. So as per the DRI, on average, we require around 0.8 grams of protein required per kilogram of body weight. So depending on how established you are, it's a little cut off, but the population average is around 0.66. But if you're an established athlete, you need around 1.2 to 1.6 grams of protein per kilogram of body weight. Now, what does that look like? So this is super cool. There's me. At roughly 95 kilograms, 215 pounds, 220-ish, I'm aiming to get around 170 to 200 grams of protein per day at the very max. And 1.79 to 2.1 is even higher. So again, I could be getting away with less, but it's normal for me to burn over 4,000 calories a day. And when I was training for Ironman training and also for bodybuilding, I was vegan, plant-based pretty much. So it's possible to get those amounts of protein naturally and still maintain muscle mass. And the reason for that being is that we just don't create muscles all that quickly. So we don't really need 400 grams of protein. It's just going to get wasted. We're gonna shit it out. And so what does that look like? This is pretty interesting. For a day's worth of protein at, for me, 6'5", 215 are 3.5 chicken breasts or 2 servings of meat and 4 protein shakes and the next amount. This is for obviously natural athletics, for normal protein synthesis. For somebody that is of my stature, this is what a daily intake of protein requires. Now, this is a lot more dense. This is cool. This is a lot more dense than this, right? Plant-based source of protein, not obviously processed, but this is a lot more dense. So it's much easier to get protein requirements in a day, and if you're eating animal-based, but you're going to reap the repercussions from that down the line. And yeah, in terms of, we hear this all the time, plant-based amino acids. So the thing is that because plant-based source of protein aren't as dense, they don't just contain a big juice or a big punch of all the amino acids in one. They're just spread out across the rainbow of foods that you're supposed to consume. So whole grains, legumes, seeds, nuts, broccoli, mushrooms are excellent sources, but they're usually categorized as incomplete proteins because they do not contain high amounts of all of the amino acids, if that makes sense. But if you eat a wide variety of fruits and vegetables and stuff like that, you're going to get all your amino acids. And if you're struggling to get in your amino acids as a vegan or plant-based individual, you can just take a BCAA supplement. Super good. It goes in your water and you taste like mojito. Why not? So yeah, that's just a little bit more of the science behind amino acids and some relevance. So pretty much we can slowly start coming to the conclusion that we don't need to eat that much meat to build muscle. And obviously here we're going to venture a little bit. He's 24 years vegan. So here's what he eats in a day. Like, for example, like it's possible to not eat animals and gain large amounts of protein, for example, right? So the evidence is definitely out there, and it's going to be a journey in terms of figuring out what foods you react best with, what protein sources you react best with. Like, for example, I don't react well with beef products. Beef just doesn't hit me properly. But doing this type of research and gathering the information and understanding the different types of protein is key in furthering your development and being actually healthy, because you'll actually know what to eat and what to avoid. And yeah,